Okay, let's look at classifying matter. In order for us to do that, there's two useful definitions that we need to take notice of. Firstly, matter is anything that has mass and it occupies space. So it has two measurable quantities. First of all, the mass and the volume. Now, there are literally millions of different types of matter. So let's narrow it down by saying a substance is a particular type of matter with a unique set of physical and chemical properties. So we have many, many different types of substances that all grouped together we can say make up matter. So how do we go about classifying matter down a little bit further? So we said before we've got substances, so we're going to take that into our definitions. So the broad category of matter, first of all we can have what are called pure substances, and these are what we call homogeneous substances. Homogeneous, we've got one type of substance. Now we can further break down these pure substances into what we call elements, which are made up of one type of atom, and compounds, which are made up of at least two different types of atoms. So we've got an example here would be silver, and as a pure element, and sodium chloride being two elements joined together would be an example of our compound. Now we can also classify matter not only as pure substances or homogeneous substances, but also as mixtures of two or more different types of substances. In this case we get what are called heterogeneous substances as opposed to homogeneous substances. And as I said just before, these have at least two different types of substances in there. Now they're to be distinguished from compounds because the compound has only one type of substance. So these ones over here are made up of at least two types of substances. Now we can further classify our mixtures into two groups. First of all, we can have what are called solutions, and solutions are made up of one phase. So we actually say they're homogeneous as well, but not to be not to be confused with our pure substances over here. We've actually got a mixture, as we said before, of substances. So we look for whether they've got one phase only. Are they separate substances or separate mixtures of substances, or are they do they have multiple layers? So our homogeneous mixture will have one phase only. And a good example of this would be a cup of coffee. Yes, we have coffee in there, we may have milk in there, we'll have water in there, but they form one phase. It's completely mixed together. Another example might be salt water in the ocean. If there's no particulate matter in there, we've got one single phase only. So on the other hand, we can also have heterogeneous mixtures made up of two or more different phases. So we get a mixture that has different layers in there. An excellent example would be our salad dressing. We've got vinegar in there, we've got oils in there. Normally they don't mix, so it's a heterogeneous mixture. But if we shake it up, we can simulate having the one layer. Now another good example, if we add to our salt water over here, which was our homogeneous mixture, or one phase, if we add sand into that particular salt water mix, they don't actually mix together into one single phase. Instead, they're two separate phases. So we call that a heterogeneous mixture.